All right, our first problem, number 48, it says using a box plot to measure spread. Just to make note, we have included our box plot from the year 1975 and our box plot from the year 2000, and I tried to line them up as best I could so that they had the same scale, so that you could kind of compare the box plots together. So it says, by looking at your box plots from problems 46 and 47, determine which year of temperature data has the greatest range. Okay, well, remember, range is the largest number minus the smallest number. So largest minus the smallest. Largest minus the smallest. I don't even have to do the math to know which one has a bigger range, and I don't think you do either. Therefore, we can go and write down our answer. If you haven't written it down yet, go ahead. If you haven't written it down yet, pause and think, and then write it down. But the year 1975 has the bigger range. Its arms, right here, extend much farther than the arms or the whiskers of the box plot from the year 2000. Okay, let's move on to letter B. It says, in addition to the range, there's another way to calculate spread. The interquartile range, they will abbreviate it using the letters IQR, is found by calculating the difference between the third quartile and the first quartile. It is the range of the middle 50% of the data. Calculate the interquartile range from the temperature data from 1975. Great. So I'm finding quartile 3, which is right here, and then I'm subtracting from it quartile 1, which is right here. If you haven't done so yet, subtract those two numbers. If not, continue watching the video. I'm going to line up my two numbers, 73 minus 56. I'm going to have to do some regrouping. 13 minus 6 is 7. 6 minus 5 is 1. Okay, so I'm going to go ahead and write up here for B, the interquartile range is 17. Now it says, calculate the interquartile range for the temperature data from the year 2000. So I'm going to go ahead, use a different color. Okay, so locate your quartile 3 in the year 2000. That's right. Good, 75. And then locate your quartile 3, your first quartile, or your quartile 1 for the year 2000. Good, 54. Now we subtract those two numbers to get the interquartile range. If you haven't done so yet, go ahead and pause the video. If you have, continue on. 5 minus 4 is 1. 7 minus 5 is 2. This is 21. Letter D says, now which year of temperature data seems to have the most spread measured with interquartile range, or IQR? So it's just asking which one has the biggest number, which year. 1975 had 17, and the year 2000 had 21. So which year seems to have the most spread measured? So this would be the year 2000. And letter E says, what advantages are there in using the IQR to measure spread instead of range? So what would be something that's good about measuring it this way, the spread of data? If you haven't written anything down yet, go ahead and pause and put down your best thinking. One of the things that jumps out to me is that when you're doing the IQR or the interquartile range, it's not using any outliers. So it's not using any of these data points here, or the high points, maybe there was an outlier on the upper end of the data. But IQR basically just takes the middle half of the data, so it's not affected by any of the outliers, so it won't make the range seem really big if there are outliers present.